Hello students, welcome to RLD Academy. In this video, we are going to solve this math problem. It appeared in IIT JEE Main 2020. This problem is about finding the range of function f where function f of x is given by this one. Here one function, this denotes one greatest integer function. So this problem contains one greatest integer concept. Okay, so we need to understand what is this function, and then we'll try to find out the range of this function for the interval of the input. This x is 1 to 3. Now we'll start discussing on the greatest integer function. So this greatest integer function will use these two symbols, this symbol or this symbol. There is one difference. This is only this side, there is one third bracket. Okay, in top it is not given. Generally this is used for float function. So you want to imply greatest integer function as this is equals to n if x is within n to n plus 1 where n is integer. So here it is equal sign, n less than equal to small x less than n plus 1, n is integer. For that, this greatest integer function will give you this integer n, small n. For example, if I consider 2.5 and its greatest integer value is 2 only, because 2 is the integer part and 0.5 is the decimal part, right? So this is your 2. Similarly, 3.9, its integer value is 3. However, for negative minus 2.5, what would be the integer value? Now you can note here that this minus 2.5, this x will lie within minus 3 to 2. Okay, be careful here. So this will start from minus 3 equal to, and it is up to 2. Within that you will find minus 2.5. This also we can write this way. It is minus 3 plus 0.5, and minus 3 is integer part. Okay, and so its value is greatest integer function will give you the minus 3 integer value. Okay, so be careful about these negative numbers. And this one, if I want to find out greatest integer value of x plus m, where m is another integer, in that case we can replace this one by greatest integer value of x plus m, because m is integer that I can take outside. Sometimes this will be useful. Now we'll look at our problem. This is the function given, f of x equals to x times greatest integer function of x upon 1 plus x square. But this function we need to calculate only for x equal to x within 1 to 3. This interval, 1 to 3 interval of x. Okay. Now in this interval you can see there is one integer, that is 2. So we can have two intervals we can consider. One is 1 to 2, another one is 2 to 3. Thus we can have two values for this greatest integer of x. Thus f could be written as 2a. We'll consider one range, one interval for x as 1 to 2, and other will consider x interval as 2 to 3. Here it is open, and here we will start from 2, exactly 2, equal to 2 and up to 3, and this is again open, this is closed, including this 2, right? So these are two intervals we have considered separately. For this interval we can write this greatest integer value of x would be this integer only. This is 1 because it is 1 to 2, so this integer is 1. Similarly for this one, its integer value will be only 2. Okay, so we can replace this greatest integer function of x by these two values 1 and 2 for these two ranges separately. Thus for this one here, this one is replaced by 1, thus it will be 1 into x means only x upon 1 plus x squared. Similarly for this interval we will get 2 times of x, because this value is 2 times of x upon 1 plus x squared. So this function will have two different shapes for two different intervals. One is for 1 to 2 is this one, and for 2 to 3 is this one. Now here you can note that this function is one kind of function, that it is x upon 1 plus x squared times some constant. Here constant is 1 multiplied, here 2 multiplied. So what I will do, we will try to study this kind of function, f of x equals to k times x upon 1 plus x squared. What is the nature of this function? Where k is positive. In this case k is 1 or 2, right? But anyway, we want to understand this kind of function, whether it is growing or decreasing, or it can have some fluctuating shape. Okay, so that shape we want to understand for at least for these intervals 1 to 3, right? So for this, what we will do, we will take derivative of this function f with respect to x. So df dx, so that we can take derivative, and derivative is simply this one. So as it is 1 upon x squared denominator, here you will get the square of that one. Then k times is constant outside, and for this is constant. Okay, then derivative of 1, so derivative of x is 1 minus sign. Now x is constant, derivative of this function 1 plus x squared, this derivative is 0, this one is 2 into x, thus it is replaced by 2 into x. Now if you simplify this, it is 1 plus x squared, it is minus 2x squared, it will give you k times 1 minus x squared upon 1 plus x squared, that whole square. And now this one is always positive, it's whole square, and k is also positive. Now this 1 minus x squared, because of this one, its derivative, we can see that it will be negative for x more than 1. If x is more than 1, then 1 minus x squared is negative, and because of this derivative will become negative. But remember, if x is within 1 to minus 1, then it is positive. And you know that if derivative is positive, then the function is growing in that interval. Okay, and if derivative is negative, then function is decreasing in that interval. So I can understand that when x is more than 1, the function f of x is decreasing, and it is decreasing monotonically. So we can say that this f of x of this form, this kx upon 1 plus x squared, it is monotonically decreasing function for x more than 1. So here the interval given 1 to 3. So both the cases it is monotonically decreasing function. But you can see for this interval it is x upon 1 plus x squared. For this interval 2 to 3 it is 2x upon 1 plus x squared. Now we need to discuss these two separately. So this is the function for these two intervals. Now you understand better. We want to see the graphs of this function. Now this one is a graph for this first one, x upon 1 upon x squared with respect to x. And you can notice that this part, now when x is very small, this x squared is negligibly small compared to 1. So this is only 1, and that time this function is close to x. So it's a linear. So at close to 0, this function is x, simply x. Okay. But when x is large, that time it will dominate, and because of this total value will decrease again. But this function will grow up to x equals to 1, and beyond that it will decrease. So it's an increasing function from 0 to 1, and then it is decreasing function. Okay, so here the first one for interval 1 to 2, just need to consider only, that time it will decrease. Okay, from here to here. Now for the second part, this one, this is just simply 2 times of that. Okay, so this is 2x slope. Okay, it will grow up to 1, and beyond that it will decrease. But here interval we will consider 2 to 3. So this to this. So this function will start from here and up to this. That only we need to consider. Okay. Now we need to find out the range of this function. Means the value of f of x that will vary for this interval. Okay. Now for this interval, it will vary from this point. Okay. So what we can do? We can start when x equal to 1, its value could be here. Okay. And when x equal to 2, it will reduce to up to this level. So this will be the one range, okay, for this interval, right? This to this. This value we can calculate, we will calculate later. Now for the second interval, again from here, you can see, because it will start from 2 to 3, at 2 it will have maximum these things, and at 3 it will decrease to this value. So this is another interval. Okay, another range I can say. This is the one range for this interval 1 to 2, and this is another range for this interval 2 to 3. Okay, now what are these values that we can calculate? So it is very easy. So at x equal to 1, what is the value of this one that I need to calculate, and x equal to 2, what is the value of this one? For that we will consider this function x upon 1 plus x square. So you can see, so when x equal to 1, its value is 1 upon 1 plus 1 square. It's simply half this one, the highest one. And when x equal to 2, its value is 2 upon 1 plus 2 square. It will give you 2 by 5. Okay, so this is 2 by 5. So this is the lowest one, this is the highest one. This is the range, 2 by 5 to half. Now similarly for this one, this interval 2 to 3, you can see, so when x equal to 2, its value is 2 into 2 is 4, and denominator is 1 plus 2 square is again 5. Okay, and for this one, next one, when x equal to 3, 2 into 3 is 6, and this is 1 plus 3 square is 10. So 6 by 10, I can write 3 by 5. So this is 3 by 5, this is your 4 by 5, this is the range 3 by 5 to 4 by 5. So we need to combine these two range, they are not overlapping. Okay, so range of function we can write as this 2 by 5 to half, this is for this first interval, 2 by 5 to half, will take union with second interval 2 to 3. Here you can see this is your close, okay, including 2. 2 means the highest one is 4 by 5, okay, and 3 will go for 3 by 5 here, corresponding lowest one. So this is again open, okay, be careful here. So here range is 3 by 5 to 4 by 5, but it is close, including 4 by 5, because here 2 is including. Okay, so this is the range of this function. Okay, and for this problem, these 4 choices are given, and you can see this is the closest one. Only thing is that here it is not given third bracket, not excluded thing is given, but exactly it should be included. Okay, I hope you have got this concept, and if you enjoy this video, please press the like button, and if you want to get this kind of videos in future, you may subscribe this channel. Thanks for watching.